Okay, learners, let's have a look at another question, still brought to you by ICampSA. And on this one, we are looking at our practice problem number 3, that is from the 2022 November final paper. And this question requires us to determine the value of k. If you look, k is just at the top of our sigma notation there. And there's something that I need you to remember before we even get into this problem. And this is about sigma notation in general. So our Sn, which is the sum of n terms, is always the same as our sigma notation, starting from k is 1 up until n, and here we will typically have tk. There's two things I need you to pay attention to, which is that the n is what we have on our sum, but most importantly, what we start with here is 1. So it means from our problem, we need to ensure that here we start at 1 if we want to use the sigma or the sum formula. So what we can do is we can go now and say our sum, which is from p is 0 up until k of 1 over 3p plus 1 over 6. What we can do is we can make it start from 1 by taking the p and substituting it here. So we'll have 1 over 6 into, it's 1 over 3. So we'll have 1 over 3, we'll use the 0 already, and then plus 1 over 6. Then since we've used the 0, we can now go ahead and start from 1. So our p will be from 1 up until k, and we have what we had, 1 over 3p plus 1 over 6. Now this we are happy with, okay, because we can now, if we want, use the summation formula. And remember, what sits there is actually p tk. So what you should see is that our TP, our formula, is what sits there. So it is that 1 over 3 p plus 1 over 6. Okay, so that is what we have. So essentially our sum will be given by that. So if you look carefully, if we quickly go back, p equals 0 up until k of what we have there, which is 1 over 3p, and then plus 1 over 6. This will just be equal to 1 over 6, and then plus this summation here. So that is what we have. So what we know from this sigma sign here, or from this portion here, is that what sits there tells us of the number of terms. So it means that we have k terms. So what I'm going to do then is to use our summation formula to be able to solve for the k. So if you think carefully, I can find tk. Tk, if you think about it carefully, it will be the last term. And the last term will just be us putting k wherever we see the p. Remember, this is tp. So it will just be 1 over 3 times k plus 1 over 6. And then the first term of the series, we just need to put in 1. So remember, we can do a. And at a, remember, we are putting p is 1. So we'll have 1 over 3 into 1 plus 1 over 6. And if you do the math here, you will see that what you will end up getting here is just a half. So that becomes your first term, which is just going to be T1. Now with this in mind, we now know how to use the summation equation. So this means that our sum of k terms will just be, if we look at that summation here, if we look at this portion only, where we have p equals 1, and then we have k of that 1 over 3p plus 1 over 6. This will just be the same as the equation, which we are going to use the one where we are using the first and the last term. Let me show you which one is that. So we are going to use this equation where we have n over 2, or we are going to use k because we have k terms, over 2 into a plus l. So that is the one which we are going to use. So it means we are going to have k over 2 into the first term. As you can see, it is a half. And the last term there, let's go ahead and add it. If you look carefully, the last term is just given by 1 over 3k and then plus 1 over 6. So that gives us that portion there, which we are just going to call it, that is sk. That's the sum of k terms. So if we go ahead and have a look at our sk, you will see that we'll just have k over 2 into, inside we have 1 over 3k, and then plus, when we add half with 1 over 6, what we end up getting is 2 over 3. So that is what we have. Now we can go ahead and start evaluating our sum to what it is equal to. So if you look carefully, we have p is 0 up until k, we have 1 over 3p plus 1 over 6, of which this will just be 1 over 6 plus sk. And we are given, we know what sk is, we'll use it to solve for k, but we are given that this is all equal to 1 over 6. So we'll go to the next page and then start worrying about these two. So this must be equal to that. We just need to solve for the k from this expression. So let's go ahead and solve for k now. So if you observe carefully, what we are going to have, if you look at the left hand side, we are going to have sk, which is all of that, and then plus 1 over 6, which is equal to 1 over 6. So I'm just going to quickly multiply through here. So if you look carefully, what we are going to have is k squared divided by 6, and then plus 2k divided by 6. I'm going to make a common denominator shortly, and then plus 1 over 6, and this is 1 over 6. So if you remember how this works, is it's 20 times 6 plus 1, all divided by 6. So if you look carefully, in order for us to eliminate that denominator of 6, we can just multiply by 6 on both sides. So I'm going to introduce a 6 on the left, but also introduce a 6 on the right hand side. So this 6 is going to cancel nicely with all of the other 6, such that the answer which is left is just k squared plus 2k plus 1. And then on the other side, if you look carefully, 20 times 6, that will give us 120. And then plus 1, that will be 121. And then now we're in a position to just quickly transpose all of this and bring it to the other side, such that what we now have is k squared plus 2k minus 120, and this will be equal to 0. Next, what we need to do is to worry about factorizing this portion. So we need two numbers. When you multiply them, you get negative 120. But when you add them, you get positive 2. So if you think about it carefully, that should be a 12 and a negative 10. Okay? These are the two numbers that multiply to negative 120, and they will add up to positive 2. So if you observe carefully, we will clearly find that our k plus 12 will be equal to 0, or k minus 10 will be equal to 0. So when we solve here, we'll get two k values. You'll get a k of minus 12, or we get a k of 10. So remember where the k is. K tells us of the number of terms. Remember that. K equals the number of terms. So now when you look at the two answers which we have k is negative 12 and k is positive 12. So the correct answer here should be k is 10, because we can't have negative 12 number of terms. So the correct answer for our problem is k equals 10. I hope this does make sense and you understand all the rationale which we put into this question. I suggest that you do pause now and then attempt the question by yourself. But this here was a very important fundamental which we needed to understand to get this question done. I hope it does make sense and you actually understand what is going on. So let's go to the next question.